In this video, we talk about diffuse samples. Diffuse samples are actual GI bounce light in your scene, how the light interact within our scene. Without GI samples, we only see the effect of the direct lighting. When diffuse sample value is bigger than 0, camera rays hitting a diffuse surface fire indirect diffuse rays in random directions within a hemispherical spread. So if you take a look at this picture from Arnold's port page, as you can see, a camera ray is fired. When this ray hits a surface, indirect diffuse rays will be generated. As you increase your diffuse samples, you are increasing the number of indirect diffuse rays fired from those hit points, and by doing so, reducing indirect diffuse noise and getting a higher quality GI bounce. Now let's go over this concept quickly. The same scene we worked with in our previous lesson with some minor adjustments. I have turned off all the lights in the scene except for this key light from the left side, and this will help us to understand diffuse sampling a bit better. This is the render that we are getting by default. For this lesson, I'm not interested in textures or material reflections and just want to see a pure clay render. To achieve that, we can turn on debug shading mode in the IPR. Right click on it and make sure debug mode is set to diffuse, and now we see a clean clay render. Let's open our render settings. We have 3 camera samples and 2 samples for diffuse, specular, and transmission rays. Now let me decrease all the sample values to 1. If I run IPR, we are gonna have this noisy render. Now let me zero out my diffuse samples, and as you can see by looking at the IPR, we no longer see any indirect lighting or GI. Right now, we only can see the effect of the direct lighting. So if a light ray hits a surface directly, it will illuminate it. And for other surfaces, as there is no indirect lighting, they will be dark and pure black. As soon as you have a bigger value than 0, like 1 for your diffuse samples, you start to see the indirect lighting and the effect of global illumination or GI. You notice how those previously dark renders are now getting some indirect lighting and therefore they are brighter. We can actually individually see our diffuse direct and diffuse indirect render passes, or AOVs. If you go to the render settings and AOVs tab and search for diffuse in the inactive AOVs and add diffuse direct and indirect to the active AOVs list, and if I run the IPR, we can take a look at our diffuse direct and indirect passes separately. So here is our diffuse direct, only the effect of direct lighting. You can see underneath the objects where no direct light can reach is black. And in the diffuse indirect pass, we can see the indirect lighting. And if I zero out the diffuse samples, you can see this AOV becomes completely black because there is no indirect diffuse rays introduced to the scene. And as soon as I increase the diffuse samples to 1, we start introducing a very noisy indirect lighting or indirect diffuse or global illumination. Now what we have is physically correct, and our only concern is how to improve the quality and reduce the indirect diffuse noise. We can do so by increasing the number of our diffuse samples. Now remember, it's possible to increase the diffuse sampling quality by increasing the camera samples, but that would affect everything else in the scene. So if we made sure the origin of the noise is GI diffuse, we can increase the number of our diffuse samples without affecting any other thing in the scene. So when we are increasing the number of diffuse samples, unlike camera samples, we are only increasing the quality of our indirect diffuse rays without affecting other ray types like camera, specular, transmission, or subsurface scattering. Let me increase the diffuse samples from 1 to 6, and if I render the scene, the result would be like this. If you look closely, even though the render is very noisy, still the areas affected by the indirect rays are much cleaner. If you take a look at this area underneath this object, it is much cleaner compared to the previous render when we had 1 diffuse samples. In each and every scene, you need at least to have 3 or 4 camera samples to handle at least anti-aliasing. Additionally, you might have depth of field, motion blur as well, so let's cover that base by increasing our camera samples to at least 4. Now that we have our 4 camera samples, our diffuse samples are much bigger. In fact, it's 16 times bigger, because as we learned, the actual diffuse sample is diffuse sample squared multiplied by the camera sample squared. So 6 by 6 multiplied by 4 by 4 36 by 16 equals 576 diffuse samples. Now that we have increased our camera samples, we can decrease diffuse samples to around 4, which gives us 256 samples. And that could be enough for most cases, but let's leave it at 6 for now. We still have some noise in some parts of our render, but they are definitely not caused by GI diffuse samples, and the reason for the current noise are the low value of direct light samples. We can check out the diffuse direct pass again, and this one contains the direct lighting of our scene, and you can see it's very noisy. So to remedy that, let's increase the samples for the lights that we have in the scene to about 5 and wait for the IPR. And now we're going to have this clean render. There are still some noise around, but this is a clay render without any textures, and textures tend to hide a lot of noise as well. And obviously we can still increase our diffuse and light samples to get even cleaner renders. Two things to remember though. First of all, remember the actual number of diffuse samples are the input squared multiplied by the camera samples squared. And also use diffuse samples sparingly because it's going to have a huge impact on your render time. For example, if you saw some GI diffuse noise, increase this value to, let's say, 3 and see if the noise is gone. The default value is 2, I think, for the diffuse samples. If still there were some GI noise, then increase it to 4 and just like that. In this lesson, we discussed diffuse samples, and in the next lesson, we are going to talk about specular samples. See you there.